In this video, we will investigate rates of change and the behavior of graphs. In this video, we want to start by talking about rates of change. We want to find the average rate of change of a function and use a graph to determine where a function is increasing, decreasing, or constant. So just as a warm-up, let's list the first 10 prime numbers. So numbers that are prime are numbers that are only divisible by 1 and themselves. So the first 10 would be 1, 2, 3, 5, 7, 11, 13, 17, and 19. Notice they're all odd except for the number 2, because any other even number would also be divisible by 2. We also want to use these prime numbers to kind of simplify fractions. So for example, if we're looking at 12 or 24, we know that that reduces to 1 over 2. Now, one thing I wanted to make you aware of, if you're using a graphing calculator, a TI, you can use Math and then click the button that says Frac and then Equal. So if you were to put 12 divided by 24 in your calculator, it's going to give you 0.5. But if you wanted to turn it into a fraction, you'd do Math, Frac, and then the equal sign. So 28 over 16, these are both divisible by 4. It's 4 times 7 and 4 times 4. So we would get 7 quarters. So in algebra, any higher mathematics, we're not going to write that as 1 3/4. We're going to leave it as an improper fraction, 7 over 4. So 30 over 78, those are both divisible by 2. So let's do 2 times 15 and 2 times 39. So those will reduce. And these are both divisible by 3. So let's write this as 3 times 5 and 3 times 13. And we'll get 5/13 as our result. These last two are kind of special. When you have 0 in the numerator of a fraction, the result is 0. And if you have a 0 in the denominator, this number is undefined. Does not make sense because we cannot divide by 0. So when we talk about the average rate of change of a function, we want to describe how the output quantity changes relative to the change in the input quantity. So we usually have a rate that is output units per input units. The average rate of change between two input values is the total change of the function values divided by the change in their input values. Now you may have seen this before. If it's linear, we call this slope. So if we had two order pairs, x1, y1, and x2, y2, we would take the change in the y's, y2 minus y1, those are the outputs, in relation to the change in the inputs, x2 minus x1. And the way that I have it written here is I use function notation rather than the y values. If it's nonlinear, the ratio is just called the average rate of change as opposed to slope. So let's find the average rate of change for the given functions or graphs. So for example, if f of x is 2x squared minus 9, and we want to find the average rate of change from 2 to 5. Well, what I need to do there is find the function value at 2 and the function value at 5. So plugging 2 in, I'm going to get 8 minus 9, or minus 1. And plugging 5 in, I'm going to get 50 minus 9, or 41. So my average rate of change here for this interval is going to be change in the y values over the change in the x values. 41 plus 1, 42 over 3. We can do that again for the interval from 4 to b, but we would need the function value at 4. So plugging 4 in, I get 4 squared is 16 times 2. 32 minus 9 is 23. And if I plug the b in, I'm just going to get 2b squared minus 9. So our average rate of change here will be the change in the y values or the outputs. 2b squared minus 9 minus 23 over b minus 4. And then this last one, 3 and 3 plus h. I need to know the function value at 3 and the function value at 3 plus h. So the function value at 3 is 18 minus 9, which is 9. And the function value at 3 plus h, I will plug the 3 plus h into the function, minus 9. And I'm going to multiply this out. So I'm going to FOIL and get 2 times 9 plus 3h plus 3h plus h squared, or 18. This is 6h times 2 would be 12h plus h squared minus 9. All right, we're going to put those together in the next step. So our average rate of change here is going to be 18 minus 9. So 9 plus 12h plus h squared, that's this simplified, minus 9 all over 3 plus h minus 3. So we get 12h plus h squared because the 9's add to 0, and h. And if I reduce by a factor of h, I get 12 plus h. So the average rate of change between 3 and 3 plus h is 12 plus h. So I can do that, obviously algebraically, but I can also do that on a graph. So I want to find the average rate of change from x equals 1 to x equals 5. So I'm first going to mark x equals 1, which is the ordered pair 1, 5, and x equals 5, which is the ordered pair 5, 7. And I'm going to find the slope, or the average rate of change between those two. So I'll change the difference in the y's, 7 minus 5, over 5 minus 1. So 2 over 4, or 1/2. So what that means really is that if I go up 1 and over 2, up 1 and over 2, like this, I'll land back on that curve from x equals 1 to x equals 5. We also want to be able to talk about the behavior of a graph and whether that graph is increasing, decreasing, or constant. So we say that a function is increasing on the interval if from left to right the function values increase. They get bigger, like this. And it's decreasing if from left to right it goes down, and it's constant if from left to right it stays flat. Now this is like the formal definition. If a is less than b, then the function value at a has to be less than the function value at b. That would be increasing. And these two formal definitions are very similar. But what we need to know is that from left to right, is the function going up, down, or is it flat? So we're going to identify the intervals over which the function is increasing, decreasing, and constant. Now this is an interval of the domain, so we want to look only at the x values. So this is the function x cubed minus 12x, and I'm going to indicate on here the high points and the low points. So on this point right here, we have negative 216. And down here, the low point, we have 2, negative 16. And then you'll also notice that these are arrows at the end, meaning that it will continue on. So when we read this graph from left to right, if we were drawing this, our pencil would go up until we got to the point negative 2. So this is going to increase from negative infinity to negative 2. Notice I'm only using the x coordinate. It is also increasing over here from 2 to infinity. So again, that's when my pencil would be going up from left to right. It's decreasing in here. And again, we're only using the x coordinates, so from minus 2 to 2, like in this region here, it's decreasing. And in this particular case, there is nowhere where this function is constant. Now notice that we always use the parentheses because at a particular point, like right here at negative 216, it's just a point, so it's not going up or going down. And I can't include it in one because it could also be included in the other. So we're just going to use parentheses when we talk about intervals of increase and decrease. So one of the things you want to note is these intervals should only use the x values. So I recommend writing down those ordered pairs before you get started.